Hi guys. So now we're going to learn about the very last way to solve and to analyze the quadratic functions. Done factoring, taking square root, quadratic formula. You just learned about completing the square. Now we're going to talk about graphing and then their transformations. All right, so this looks really intimidating. Don't let it be. Okay, it's a pattern for all transformation of functions, whether it's a quadratic or a cubic, a linear, whatever it is. So the number in the way front, it will flip if it's negative on the x-axis. It will like make the thing turn down. Quadratic function, by the way, a normal one. The parent function, the normal one, like if you hang on, I want to show you. Like if you go to if you go to y equals, which is right here, and you type x squared, and then you go push graph, the normal quadratic function is just a u, right? And that u is called a parabola. FYI. All right, so if the number in front is negative, like a -2, -3, -1, it's going to flip on the x-axis. If the number is between 0 and 1, 1/2, 1/3, 2/3, 1/4, a fraction, right? It's going to shrink. It's going to become skinnier. That is incorrect. That is backwards. These are backwards. If it's a fraction, it's going to get wider. If it's greater than 1, it will get skinnier. It will shrink. All right, so it's opposite of what you think. You don't need to memorize this right now. All right, we're not really going to do much with the number touching x. There will be a number being added or subtracted for x. If that number is positive, right, it's opposite of what we think. So if the number is positive, he's going to move to the left. If he's negative, he's going to move to the right. And the reason it's opposite of what we think is because he's already a negative to begin with. Then all by itself, there'll be a number being added or subtracted. If that number is positive, he will move up. If that number is negative, he will move down, right? That seems very complicated. I promise you it's not. All right, so the number all by itself moves up and down. The number with x goes left or right, and it's opposite of what we think. The number in the front makes it open. We should have said flip. Makes it really like open, up or down. Why is there not? Oh, okay. So here we are. Right here is the number we're looking at. -4. So all we need to figure out if he opens up or if he opens down, and it's a negative. So since it's a negative, he's going to open down. I hear my dog. All right, I'm going to verify that with you in a minute. Then we have 2 here. 2 is positive. He's going to open up, and here's what I mean by that. All right, so I'm going to y equals. I'm going to type in negative 4x squared. Then I'm going to hit graph. I'm going to hit graph. I want to show you something. Alright, that's the negative 4x squared, and then the lighter one is just regular x squared. Notice the darker one, negative 4x squared, opens down. Right, so when it's negative, he opens down, he flips. Now let's look at Right, now I'm going to go to that one over there, the second one. Alright, that's the, okay, the parent one is the darker one, x squared, and then the first one that you can kind of hardly see because covered up is the 2x, this one. So he still opens up, he's just shifted, he's translated, he's transformed to a different spot, but he still opens up. Right, now let's look at how 8 versus 1/4. Right, is it going to make it wider? Is it going to make it skinnier? Is it stay the same? All right, according to our little chart, if it's between 0 and 1, it gets wider. If it's greater than 1, it gets skinnier. Let's double check. There we go. 8x squared, and then 8x squared. All right, that's x squared. That's 8x squared. So notice 8x squared got skinnier. That doesn't seem to be spelled right, but sure. All right, 1/4, whoopsies, x squared. So 1/4 x squared. All right, that's x squared. That's 1/4 x squared. Notice that it's way wider. All right, so now let's look at some of the other things. Now we want to find the y-intercept. Remember, the y-intercept is when x equals 0. So all we have to do is do negative 3, 0 squared minus 6 times 0 minus 5. I'm going to type that in my calculator, just like I'm going to type this one on my calculator. 2, 0 minus 3 squared plus 11. All right, let me type that one in my calculator first. Negative 3, 0 squared minus 6 times 0 minus 5. And I get negative 5. So the y-intercept is negative 5. And remember, intercepts, x and y-intercepts, you put them as an ordered pair. All right, so this other one, I'm going to put 2 parentheses, 0 minus 3 squared plus 11. And I type that one in. I get 29. So the y-intercept would be 0, 29. The y-intercept, you have the number in the y spot. That's the x spot, and that's the y spot. And the x-intercept, you have the number in the x spot. All right, vertex. So the vertex, when it's written in this way, by the way, is called vertex form. When it's written in the other way, which is like x squared minus 9x plus 20, okay, that's called standard form. I don't need you to know the two names. I need you to know there exist two ways to write the formula. All right, the reason this is called vertex form because the vertex is HK. All right, and H is always opposite. So we're going to do this guy and this guy. So we're going to do 3, 11. And the vertex is like where you take the parabola, okay, and where you can, like the center is. And if you folded the parabola in half, it would line up. Or, there we go. If it was upside down, then you could fold it like that. It would be like the top point. So it's like the super top point, the maximum, or it's the super low point, the minimum. So like 311 would be like here. All right, 6, -2, that vertex is -6, 2. Remember, the H is opposite because the original formula has a negative right there. Then this guy over here, there's nothing in that X in parentheses, and there's nothing over here, so it's 0, 0. So it looks like that. Oops, pretend that's right on 0, 0. This guy looks like this. All right, so the vertex is H, K. So we're going to write the equation with this vertex. And so we're just going to follow this point, and we're just going to assume A is 1. We're not going to put anything there. So all we have to do is write f of x equals this guy. F of x equals that. All right, so this is opposite. So we're going to write x plus 2. Excuse me, and this is normal, plus 4. And so that's the equation. Then here, this is opposite, so we're going to write x minus 4, and this is the same, minus 2. For real, because the vertex is H. Okay. H is always opposite because he's negative. Right? The transformation. So the vertex tells you the original vertex, the original parent function looks like this. All right, and so so this vertex is at 0, 0. Okay, over here, the vertex moved and was at, so the original guy was here, and the vertex moved and was at -2, 4. So he was, I don't know, whatever, somewhere over here. Okay, and so he moved left 2, up 4. I'm going to show you how I knew that so fast in the next slide. This guy, the original parent is right there. Okay, and then he moved here. He's at 4, -2, so I went 4 down -2. And so he moved right 4 down 2 from the original parent function. And so I got left 2 from here, from there, and so left 2 was this way, 2. And then I got up 4 from here, so from there I went up 4 to that point. Here I got right 4, because remember it's the opposite, so I went right 4, and then right 4 right there as well, and then I went down 2 from this number, that number, so I went down 2. Alright, so let's look over here. The vertex here is 1, 6, remember it's opposite, and so he's going to go, remember our thing at the way beginning, he's going to go right 1, up 6 from our original guy, right 1, up 6. So he's like over here. And then we have this guy, he's going to go left 5, down 7. Left 7. He looks like this from our original guy. Alright, let's go to the next video and so I can explain it some more.